Alright guys, welcome to the test review for discrete math. This is chapters 12.1 to 12.5 in your book if you wanted to have something else to look at to help you get through this test. Alright, the first four questions talk about summation notation. Now, you learned this as sigma notation. It's basically the same thing. We're basically taking a sum that has been a series per se that has been given to us and rewriting it in sigma notation. So let's take a look at the first example. As you can see, the little dots there tell you that our series is never ending. We don't have an end number to it. So that means when you start with your sigma, the first thing that you should put at the top is an infinity. That infinity takes the place of this because the series does not end. The next thing you should do is put n equals 0. That's the first place that you always begin. And now let's see what this is. Is this a geometric or an arithmetic series? If this was arithmetic, we would be adding by the same number each time to get to the next number. Clearly, you can see that this is not going to be an arithmetic series because the numbers are significantly getting smaller. So let's take a look at a geometric. To see if it's geometric, what you'll do is divide 27 divided by 81 and see if it's the same thing as 9 divided by 27. And we do notice that it is definitely going to be 1/3. So basically, if you just keep multiplying by 1/3, and this does look like a power, I shouldn't put it up there like that, but you are multiplying by 1/3, and what you notice is that our ratio is 1/3. We are multiplying by the same number every time. We also need our a sub 1, which is our first term, and that's 81. Now the formula that we are going to use is a sub 1 r to the n power. If you notice anything, this looks a lot like the geometric sequence formula. It actually is the same thing without the n minus 1. And Brian Shom in my 4th period said that this looks like the word air. So if you're having a hard time trying to figure out the formula to use for this, it just looks like air if you eliminate the n. So that's a quick way to remember it. So I'm going to replace the a sub 1 with 81. I'm going to replace the ratio with 1/3, and the n will stay the same. Okay? Because we are not doing anything with the n. So now if I wanted to test this, I can do 81 times 1/3 to the 0, and this should be equal to 81 because that's my first term. Well, anything to the 0 power is 1. So yes, my first term is 81 as it was right there. So it is all good. Do you have to test this? No. I'm just showing you why we use n equals 0. Alright, number 2. The numbers here are not getting significantly higher. They're growing a little bit. So you can tell, even if you look towards the end, that this is actually adding 5 each time. So because we're adding 5 each time, we call that a difference. So our a sub 1 is equal to negative 12. So the first thing I'm going to do is make my sigma notation with n equals 0. Now, in this case, this does not end at infinity. It actually ends in an actual number. So since n equals 0, this means that this is the first term where n equals 0. This is the second term where n equals 1, and etc. So that means that 23 is the 8th term, but n equals 7. So we want to know what n equals as our last term, and that's what you put at the top. You do not put the amount of numbers, you just put the amount that n would have to be equal to get this last term. Okay, because I know people get a little confused. So what does n have to equal for me to get 23? That's what that means. So now the formula to use for this is difference times n plus a sub 1. Now, Brian did come up with another formula. He says this almost looks like data, D-A-T-A, even though this is not an A. But he says if you look at it, it kind of looks like, oh, not data, DNA. Oh, my bad. So it looks like DNA, like, you know, the DNA strand. So DNA is a way to remember this. Alright, so I'm going to erase the D and replace it with 5. I'm going to keep the n, because I need the n for my formula, and I'm going to replace the a sub 1 with negative 12. And that's it. That is the answer to the question. Alright, for the next two, I'm just going to give you the answers. So hopefully if you need any more clarification on this, you can watch how I did number 1 and number 2. Alright, so there are your answers to 3 and 4. Alright, now to number 5, which is the sum of the series. So 5, 6, 7, and 8 represent the sum of the series. So what you need to do is actually look at the series and see if it's infinite, if it's arithmetic, or geometric. So an infinite geometric series has this formula. But remember, the absolute value of r has to be less than 1. And I say absolute value because sometimes we might give you a ratio equal to -7, and you may think that you can use that ratio, but you can't. The ratio has to be, the absolute value has to be less than 1. So in order to use this formula, you have to actually check the ratio, make sure that the ratio is less than 1, and if it is, then you can actually apply this. And the only time that you apply this formula is if you see the ... representing an infinite series, or if you see an infinity in the summation or sigma notation. Alright, so number 5, we have 128, 32, 8, 2, ... So we can clearly see here that this is an infinite series, so we are going to be able to use this. And the other thing we need to check to see is that, is this a ratio bigger than 1, less than 1? So I will divide 32 by 128, or I can even do 8 divided by 132, but when I do that, I find out that my ratio my ratio is equal to 1/4. So because my ratio is equal to 1/4, it is okay to use this formula. So I'm going to apply it. And remember, you can only have a ratio. If you wind up having a difference and it's infinite, you cannot use this formula. It has to be a ratio, meaning it's an infinite geometric series. So S equals a sub 1, which is 1/28, divided by 1 minus r. Well, r is 1/4. Okay, if you do this correctly in your calculator, 1 minus 1/4 is 3/4, and 128 divided by 3/4 gives you 512 divided by 3. Alright, number 6 is 3 plus 4 plus 16 over 3 plus 64 over 9 plus dot dot dot. Well, I see that this is an infinite series, so I definitely can try to use but the one thing I have to look for. So to find the ratio, I'm going to divide 4 divided by 3, 16 divided by 3 divided by 4, etc. And I find out that my ratio is equal to 4 over 3. If you know anything about this, this is an improper fraction. Improper fractions are automatically going to be less than 1. I mean greater than 1. So since 4 over 3 is greater than 1, the sum does not exist. Or, as I affectionately like to use, DNE. Alright, so make sure you recognize when the sum does not exist. Alright, for number 7, it's written in sigma notation. So the first thing I have to look at is my ratio. If you know anything, remember the problems that we did from 1 to 4, the number in the parentheses represents my ratio. So because my ratio is equal to 3/4, and 3/4 is less than 1, I can definitely solve this problem. The other thing I have to do is actually find my a sub 1. My a sub 1 is when n equals 1, that gives me the first term, because that's what this means. So I'm going to do 2 times 3/4 to the 1 minus 1 power. Well, 1 minus 1 is 0, and 3/4 to the 0, anything to the 0 is 1. So my a sub 1 is equal to 2. So the first thing I'm going to do is apply into the formula. So that's 2 for a sub 1 over 1 minus 3/4. Now if you know anything about fractions, 1 minus 3/4 is 1/4, and 2 divided by 1/4 gives us 8. So this works out. Okay, now I'm just going to give you the answer. Infinite series sums. Alright, so if you go to the next page, you'll see that it's not an infinite series. What tells me it's not infinite is the fact that it has a starting and ending term for n. So if you look at number 9, it starts at 1 and ends at 6. And it's for the sequence 3n minus 2. Now that is definitely an arithmetic sequence, so you can solve this problem in one of two ways. So I'm going to show you both ways, and you can choose how you want to solve that tomorrow. Now tomorrow, if it's not arithmetic, you cannot solve it this way. So only arithmetic and geometric sequences can be solved in a certain way. Alright, so with this one, I'm going to do 3 times 1 minus 2 plus 3 times 2 minus 2, and etc. Now once you work this out, you get 1 plus 4 plus 7 plus 10 plus 13 plus 16. Now the great thing about this is you can add these all up together if you want and just simply get 51. Or you could have used the this arithmetic series formula, which is S sub n equals n times a1 plus an all over 2. If you notice, we have 1, 2, 3, 4, 5, 6 terms, so n has to be 6. So S sub 6 equals 6 times a sub 1 is 1. A sub 6 is 16, all divided by 2. And you'll see that it'll give you the exact same answer that we got from adding them together. So 6 times 17 is 102, and 102 divided by 2 is 51. So 2 ways of doing the same problem. Do you have to do it this way? No. You can do it this way as long as you figure out what a sub n is. Now if you wanted to figure out what a sub n is, you can just do a sub 6 using the arithmetic sequence formula equals a sub 1, which we figured out was 1, plus n minus 1 times the difference, which you can clearly see is 3. And this will give you the exact same answer for a sub 6 as we got here by doing it by hand. So you can take this a sub 6 and plug it into here. If you didn't want to write out all of the numbers, you wind up getting the same answer. If you're comfortable this way, do it that way. If you're okay with this way, do it that way. But there's 2 different ways to get the same answer. Alright, now I'm just going to do number 10. By the other way, because we don't have an a sub 1, and you need an a sub 1 to solve it this way. We are only doing a sequence starting from 3 to 8. I mean, I guess you could just renumber it instead of n equals 3, n equals 8. You could make this a sub 1, and then this would be 2, 3, 4, 5, a sub 6. And then you would solve it the same way we did the other question, even though we started at n equals 3. So I guess you could. So it does work out that you could solve it, but just changing that to a sub 1 and a sub 6, even though we started at 3. Alright, so that takes care of all the summation. Now from 11 to 14 are just working with sequences and series. So number 11 is based off of this formula. So our a sub 1 here is negative 11. You find out that your difference, once you start adding things together, you find out that your difference is 5. So we want to find out, so your n is 16 because we're finding the 16th term. So we're trying to find a16. So a sub 16 equals negative 11 plus 16 minus 1 times the difference, which is 5. And we find out that the answer is 64. Alright, number 12. It wants the first term of the sequence of a sub 9 equals 1 and r equals 1/3, which means you are using this formula. Okay, for here our n equals 9, our ratio equals 1/3, and our a sub 9 is equal to 1. So now a sub 9 goes in this area. Now, since n is equal to 9, we're going to do 9 minus 1, which is really 8. Now, the only way to get a sub 1 by itself is to divide both sides by 1/3 to the 8th power. Now, you can use your calculator, or you can figure out what 1/3 to the 8th is, and then just flip the fraction like we did in Unit 4. So 3 to the 8th, this is 1 over 65, 61, which is 1 times 65, 61 over 1. So the answer is 65, 61. This is if you decided to do this by hand, or you can just simply put it into your calculator. So doing all this, we find out that a sub 1 is 65, 61. And all this means is that if I were to write out 9 numbers, that it would start out at 65, 61, and if I kept on multiplying by 1/3, that my 9th number would be 1. That's what this means. Alright, number 13. What is the sum of the first 10 terms? We can tell right away that this is a geometric sequence, because to get from 2 to 7 you add 5, but when you add 5 to 7 you don't get 49 over 2. So I know automatically that this is a geometric series. Okay, so they want to know the sum of the first 10 terms. So that means that n equals 10, a sub 1 equals 2. The ratio, if I do 7 over 2, is 7 over 2. And that's pretty much all I need to solve for this formula. Okay, watch me put this in your calculator. So we have 2 minus 2 times 7 over 2 to the 10th, all over 1 minus 7 over 2. So you can just really just put this in your calculator, and it winds up giving you 320,683. Now I had to round up because the next number after that was 0.988, and you know that when you round to the nearest tenth, it actually winds up becoming 0.10, and the 1 gets carried on, and that's how we get the 3. Alright. Number 14 says find the first term of the sequence if a sub 11 is equal to 87 and z equals 3. So this is an arithmetic sequence. So you use a sub n equals so I'm going to put 87 in this place. A sub 1 is what I'm looking for. N is 11. And my D is 3. So now I'm just going to work it out. The only way to solve for a sub 1 is to subtract. So in this case, a sub 1 equals 57. So that means if I were to write out a sequence starting with 57 and adding 3 each time, by the time I got to the 11th term, I would be at 87. Alright, so that ends the sequences and series section. So now we're going to move on to the limits section. Now remember with limits, there are a few rules. Looking at the highest denominator in the highest, why do I keep saying highest denominator? Highest exponent in the numerator and the highest exponent in your denominator, there are a few things to consider. If the highest is in the numerator, that means when you simplify this, you're just going to get n, which means that your limit cannot exist. You won't have a limit because if you were to divide or subtract these two, it equals n. And n, when you graph it, is just a and it never ends, the limit does not exist. Alright, so we have that means that so your answer for this limit would be asymptotes that you should have remembered from Unit 4. Alright, the last is if your highest denominator is smaller than the highest denominator in the highest exponent. Why I keep saying that? So if your exponent in the numerator is smaller than your exponent in the denominator, now higher than the denominator, that means if you were to divide this n squared, and over n squared when you graph it gets really, really, really close to 0. So that's why this limit equals to 0. So it's only looking at the highest exponent. So if I were to add things to this, it doesn't change my answer. It's still going to be this. If I were to add things here, it doesn't change anything. If I were to add things here, it doesn't change anything. Alright, so now let's look at the limits from 15 to 18. is null and void. Everything here is null and void. I just need to concentrate on this. Alright, now let's look at 16. Exponent in the denominator, I notice that they're both the same. So since they're both the same, all I have to do is divide the coefficients. So this one, the limit equals 2 over 11. So that takes care of the two examples I'm going to do for you. So now you are just going to see the answers to the next two. Alright, so I hope that limits are now a little bit easier for you to see. So now we're going to get into some expansions and finding the nth term. Alright, expansions are based off of Pascal's triangle. So let me draw that real quick. You are only required to know Pascal's until 6. But if you decide you want to keep going, that's a pretty long, lengthy Pascals to be doing. So that's why we only make you do it to 6. Alright, number 19 says that you need to expand 2x minus 1 to the 5th power, which means that we are looking at this row here. So what I'm going to do is I'm going to set everything up in terms of x and y, and then I'm going to replace everything with the actual values for x and y. So in the front we have 1, 5, 10, 10, 5, and 1. So next to the 1 always starts off with x to the power that's given. So to the 5th, x to the 4th, x to the 3rd, x squared, x, and then we don't need 1 at the end. And then we're going to, we don't need a y in the beginning, but we're going to have y to the 1, because 1 plus 4 is 5, y squared, because 2 plus 3 is 5, y cubed, because 3 plus 2 is 5, y to the 4th, because 4 plus 1 is 5, and then we'll end with y to the 5th. So this represents my setup. We're going to put pluses all into it. So now I'm going to substitute everywhere that I have the letter x with 2x. So instead of x to the fifth, now I have 2x to the fifth. Now I have 2x to the fourth. Now I have 2x to the third. 2x squared. 2x. And I don't need 1 at the end. Now instead of having the letter y, I'm going to replace that with -1. Now I'm going to multiply all of my coefficients to the numbers with their powers. So the first group will be 1 times 2 to the fifth. Okay? I'm ignoring the x for right now. So 1 times 2 to the fifth gives me 32. And now I'm going to put in the x to the fifth. So the next thing I'm going to do is 5 times 2 to the fourth times -1. Well, 5 times -1 is -5. 2 to the fourth is 16, so 16 times -5 is -80. So notice that I no longer have a plus, I have a minus. Okay, next I'm going to do 10 times 2 to the third times -1 squared. Well, -1 squared times 10, that's just 10. 2 to the third is 8. 10 times 8 is 80. Notice I now have a plus. Alright, next one. 10 times 2 squared times -1 cubed. Well, -1 cubed is -1. Times 10 is -10. Times 4 is -40. Alright, next one. I have 5 times 2 times -1 to the fourth. -1 to the fourth is 1. Times 5 is 5. And 5 times 2 is 10. The last one is 1 times -1 to the fifth. That's just simply -1. So my expansion is 32x, -80x to the fourth, 80x to the third, -40x squared, 10x, and -1. And now I just add them all together. And there is my answer. Alright, so we have another expansion to do. Okay. Based on the fourth row. So we have 3x, 2y to the fourth. So first thing I'm going to do is write out the setup so I can plug things in after. So the first thing is always going to be x to the fourth, x to the third, x squared, x, and I don't need 1 at the end. And then on the next row, I'm going to have y to the 1, y squared, y cubed, and end with y to the fourth. So now I'm going to replace everywhere I have an x with 3x. So let me first write out my coefficients. So now instead of having x, I'm going to have 2x to the fourth, and 2x to the third, and 2x squared, then 2x, and then I don't need 1 at the end, And now I'm going to have 3y. Well, this will stay the same, but 3y will start off here. And then we have 3y squared. And then 3y cubed. Sorry. And then we end with 3y to the fourth. Notice that my powers are on the outside of my bracket, just like they're on the outside here. So now I'm just going to work it out. This is 1 times 2 to the fourth. Well, 2 to the fourth is 16 times 1, 16x to the fourth. This is 4 times 2 to the third times 3. So let's see. 2 to the third is equal to 8. 8 times 4 is 32. And 32 times 3 is 96. X to the third, y. So you can just bring in the variables after. Okay, next I have 6 times 2 squared times 3 squared. So 2 squared is 4. So 6 times 4 is 24. And 3 squared is 9. So 24 times 9 is 216. And I'm going to have x squared, y squared. Next I have 4 times 2 4 times 2 is 8. And 3 cubed is 27, so that's 216. So 216 x y cubed. And last but not least is 1 times 3 to the fourth. Well, 3 to the fourth is 81. So if I did this right, my x's should be counting down by 4, 3, 2, 1. And my y should be counting up by 1, 2, 3, 4. And they are. And we're done. Alright, now to the last 4 questions, and we're done with this video. Okay, 21 says, what's the fourth term of x minus 2 to the fifth? Well, let's look at x minus 2 to the fifth. That's a Pascal of 1, 5, 10, 10, 5, 1. So my fourth term, if I count down, is 1, 2, 3, 4. It's this one. So my coefficient for my fourth term is 10. Now I have to figure out what that fourth term is. So this would be x fourth, third x squared. My fourth term should be at x squared. Well, at x squared, my exponent has to add up 5. That means that the y value is set up for the fourth term. Now I'm just going to replace x with this and y with negative 2. So then I'm just going to do 10 times negative 2 cubed. Well, negative 2 cubed is negative 8. Negative 8 times 10 is negative 80. And now I'm going to have x squared and no y value. And that's the answer to 21. Alright, 22 says, what is the second term of x plus 2y to the fourth? Well, this is a Pascal of 1, 4, 6, 4, 1. So they want the second term. So this is the second term. So the coefficient for my second term is 4. So now if I just count down, it's x to the fourth, then to the third. That means the x value is to the third power, meaning that the y value, because I want to add up to 4, has to be to the first. So here's my setup. So my coefficient's 4. I'm going to replace x with x and replace y with 2y. and it's to the first power. So now I'm just going to do 4 times 2, that's 8. And there's nothing else to multiply out, so it's 8x to the third and y. Alright, so what is the x to the 12th term of x minus 11y to the 12th? Well, if we were going to do a choose, we would do 12 for that and 12 for that. And then it'll be x to the 12th, y to the 0, because these both have to add up to 12. If you notice, since it's y to the 0, I don't need that. 12, 12 is the same thing as 1. I don't need that. So basically, that's the answer. This was a trick question for what is the first term. Because the first term always matches that exponent. Alright, now for the very last question of your review. What is the x to the 5th, y to the 2nd? So without even reading the rest of the question, I can tell that this is going to be an x to the 7th type expansion. So what is the x to the 5th, y to the 2nd term of 2x plus 3y to the 7th? Well, they've already did some work for me, so I don't even need to write out a Pascal. Instead, I'm going to do a choose. It's always going to be 7 is the first number because that's the main exponent. And then the second number comes from the exponent for x. So this again is the setup. Now if you want to do the choose by hand, you can write out the first 5 numbers after 7 counting down. So 7, 6, 5, 4, 3. There we go. And we're going to divide them by 5 counting down all the way to 1. Now if you notice, we have some, we have 2 sets that are the same. 5, 4, 3 there and 5, 4, 3 there. So we can cross those out. And now we're just left with 7 times 6 over 2 times 1. Well, 6 and 3 are in the same times table. So we're left with 7 times 3, so 7 choose 5 is equal to 21. So this whole thing is 21. Now x is going to be replaced with 2x. And y is going to be replaced with 3y. So now I'm just going to work it out. 21 times 2 to the 5th times 3 squared. Well, I know that 2 to the 5th is 32. So 32 times 21 is 672. And that's 9. So 672 times 9 is 6,048. And now I'm going to apply the x to the 5th and y squared. Now remember, if they ever ask for the coefficient, you're only including the first part, which is the number, and you're going to drop the variables. Alright, well, there is your video. It took me an hour to make this. I hope somebody watches it. I'm going to place it on Edline, and I'm going to place it in your email, just in case you don't check your email. Alright, so good luck to everybody. Study hard. Remember, shoot for C or above, even though I would prefer that everybody get a B or above. But shoot for at least a C or above. Alright, good luck. I hope you can hear me on this, and I hope it's not too squeaky.